2029-30, solar and wind installed capacity total will be of around 51%. That is the study being carried out by one of our division, which has projected the total installed capacity at 870 to 54 megawatt, out of which 51% will be solar and wind. Now, the recent and present developments can be listed as projects of 50.98 gigawatt capacity are at various stage of implementation, and projects of 32.06 gigawatt capacity are under various stages of bidding. Large hydro has been declared as renewable energy sources, as I already said, and at present 46.512 gigawatt of large hydro installed capacity is there. Hydroelectric projects about 25 megawatt, totaling to capacity of 127.63.5 megawatt are at various stages of construction. So we can say that Ministry of MNRE, Ministry of Renewable Energy, and Ministry of Power, Government of India, along with all the state nodal agencies, are taking policy initiatives for achieving the target of 175 gigawatts of RE installed capacity by 2022, and ambitious target of achieving 500 gigawatt of non-person based installed capacity by 2030.
Sing the कितना नहीं लाओ 10 नहीं लाओ
Also be looked at. So this also may not be a very viable and feasible scenario. And gas-based power plants, as we all know, mostly they are stranded and insufficient capacity is there. So we cannot rely on gas also. Gas-based plants do not also appear to be a viable option to meet the demand. So now the essence of energy storage comes. Fast response energy storage solution seems to be one of the most critical needs to ensure gigawatt scale RE integration in the system. Energy storage can play a very important role in grid integration and balancing of variable generation resources by increasing the system's overall flexibility. It can improve power quality, reduce peak demand, enhance capacity of distribution and transmission grids, avoid reduce emission penalties, etc. Energy storage systems also have multiple other applications, all of which contribute to the dynamics of power system in different ways. Then, as we all know, the energy storage system can support at the generation end also, and when the demand is more, they can also serve as they can also help at that side also to cater to the demand. There are various types of energy storage systems to facilitate the integration: pumped storage, battery energy storage system, thermal energy storage system, CHP and all, primary energy storage, capacitive energy storage. But their application depends on the cost aspects, their various advantages, disadvantages, location where these are to be installed. So all these factors are to be taken into account when choosing any storage system to be deployed. There are various other criteria also for selection and choice of energy storage, that is location where they are to be installed, cycle efficiency, capital cost and quantum of investment required, operational and maintenance cost, life of the storage system, maximum duration of energy supply, availability of end of life disposal, generation, transmission, and distribution. Import dependence. We do not have medium stocks and all. We are too short of that. We do not have, so we have to depend on import. So all these factors why we think of installing battery storage systems. And to the fact that we also have limited potential for pump storage also. So we have to choose wisely which storage system we have to go with. Then space requirement also is the criteria. Availability of standards is must, which BRI is looking into it. Technical benefits of energy storage, we all are aware. Grid stabilization. Energy storage can be used to help with transmission or distribution grid return to its normal operation after a disturbance, maybe voltage instability and frequency excursions. Then grid operation support. In addition to stabilizing the grid after disturbance, energy storage can also be used to support normal operations of the grid. Power quality and reliability. Energy storage system is often used to improve power quality and reliability. The vast majority of grid-related power quality events are voltage sags and interruptions with limited or durations that can be improved with energy storage systems. Then load shifting. Load shifting is achieved by utilizing energy storage system during periods of low demand and reducing the stored energy during periods of high demand. Transmission curtailment reduction. This is mostly helpful in the wind power plants because wind power generation is always generally located in remote areas which is poorly served by transmission and distribution systems. So as sometimes wind operators are asked to curtail their production that results in lost energy production. Opportunity in this or system operators are required to invest in expanding the transmission system or energy storage system units located close to the wind generation can allow the excess energy to be stored and then delivered at times when the system is not congested. Tamil Nadu may be the case because there will be a lot of cases of wind curtailment, and time shifting is also one of the technical benefits of the energy storage system. Right. Projections for the energy pump storage system for India as per our hydro wing of CEA. Around 8,700 megawatt of additional pump storage capacity is planned by 2030. The likely capacity addition for large hydro stations during the period 21 to 2930 has been planned as 31,499 megawatt. In battery energy storage projections as per our report, for optimal generation mix report, series report, the battery capacity will be needed at 2930 is of the order of 27 gigawatt, 08 gigawatt hour with 4 hours backup by 2930. However, the calculation of SECI shows that 81 gigawatt of storage BESS will be needed, and this they have said that is because they have just calculated this by avoiding a lot of transmission lines to be constructed. But however, the basis of this is not known, but this is the figure quoted by SECI for the BESS by 2920. We all know about the challenges in adoption of energy storage systems, immature technology, high cost of storage at present, which might decrease with the time, like our optional report proves that the cost of battery will be around 4.3 crore. From presently it is around 6 to 7 crores. In low revenue base, lock-in of alternative solutions, limited technology awareness, non-availability of standards, regulatory and policy framework also is not there. We talk of green hydrogen. Base also on grid base, we do not have other regulations, proper standards, regulations and all. Some action points we have jotted down. So these are the execution challenges persisting for the under construction projects with respect to land acquisition and evacuation infrastructure, especially in the wind power segment, need to be addressed. Land issues are the main. Storage system should be decided according to the application and techno-commercial considerations. Life cycle costs, execution timelines, flexibility in sizing, deployment shall also be the deciding criteria for the selection of places instead of only focusing on the capex. Field trial and demonstration of new technologies should be encouraged and appropriate fund to be created for supporting such deployments. Here on, I would like to add that new RE technologies may also be explored like geothermal. OGC has taken up a project in Ladakh, so such new technologies may also be explored and projects may be carried out for the same. Then regulatory and policy framework must be enabled appropriately. Establishment of agencies to enable forecasting of resources and reduce errors in scheduling actual generation. Development of Indian standards corresponding to IEC dual standards for performance test and safety aspect for commercially available tests. R&D in the field of energy storage, manufacturing, design, safety aspects, recycling aspects, battery components, and disposal of solar panels. All these areas needs to be addressed. Repurposing of EV batteries for stationary applications may also be explored. Indigenization of various components of this other than battery may be taken up immediately. ACC manufacturing, PLI is expected to kickstart manufacturing of advanced chemistry cell batteries in India in next 2 years. And it is important that demand creation policies are prioritized for encouraging appropriate investments. With all the positive steps being taken by Government of India, India is all set to achieve its stipulated targets of 175 gigawatts to achieve by 2022 and a 500 gigawatt to achieve by 2030. Thank you. Thanks a lot.